The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
There's basically no uplift on the solution, or very minimal. We've done extensive wind tunnel tests with IFI in Germany, and basically with a 550 watt module, we can handle about 160 miles per hour with a category C for ASCII code, 7-10. With a 450 watt, we can handle about 170 for category C wind exposure. So it's very well suited for those high wind environments.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, high-density ground mount solar. My guest today is Matthew Lusk. He is the Vice President of Business Development for a company called Jurchen Technologies, the makers of the PEG racking system. Welcome to the Clean Power Hour.
Hi, Tim. Thanks for having me.
I've been waiting for this conversation for a few years, Matthew. I'm not sure what took us so long, but I'm glad you're here. And here we are in 2023. Everyone is freaking out about the IRA legislation because it's a gold rush, and it's good for the solar industry. It's good for the energy transition. It's not without its foibles. Check out 45Q. There are some poison pills in the IRA legislation to my listeners. Check out all of our content, if you would, at cleanpowerhour.com. Give us a rating and a review on Apple and Spotify. That is the best way you can help others find this content. And please subscribe to our YouTube channel. So Matthew, before we get into Jurchen Technologies and the PEG racking system, which I'm totally stoked to do a drill down on with you, but give our listeners some background on yourself. How did you get interested in the solar industry? And then how did you come to Jurchen?
Yeah, so I've always been interested in solar in some aspect. Back about 8 years ago, I worked for Strategen over in Berkeley, and they had a contract with the Department of Energy for listing all their energy storage projects globally to show what energy storage can bring to the world. I came on kind of as an intern to help them expand that database from 350 projects to about 800 projects by reaching out to the actual companies and having them bulk upload all their projects. And then from that outreach, I became very involved in LinkedIn and got headhunted by a recruiter that basically hired me for Belectric. And I've been part of the Belectric group for about 7 years. And then the sister company was Jurchen Technology. And about 2 years ago, I when they got bought out, I went to Jurchen Technology because they have the PEG, and I kind of believed in that product and wanted to be very involved in that and help expand that globally.
Very cool. So you've been in the industry for a while, and you've seen a lot of different products. And what do you like about the PEG? What attracted you to it?
Well, it's really simple. It's basically rebar with modules on top. So very high density. I mean, I've done it, installed some sites here in the US, just putting rebar in the ground, crimping a top plate and a base plate, and then putting some modules on top. So really unskilled workers, really easy to install, about 80 up to 80% kind of less materials. So I think that simplicity makes it available globally on a very easy basis compared to these big old pile drivers and complicated installation processes. And just putting modules out in the field is going to be where I think where the industry is going to end up going long term, switching back to the basics.
Yeah, so we will show some photos later in the episode for those watching on YouTube. But, you know, this is an east-west array, and the GCR, the ground coverage ratio, is very high. And so you're basically blanketing the field, the piece of ground, with solar panels in an east-west orientation. So the rows are running north-south, and then you've got east-west rows. There's no moving parts, and it's low to the ground. And, so it is very unique, right? We're, here in North America, we're used to either fixed tilt or single axis tracker for ground mount solar. Now this is a third option or a fourth option. You have Earthos also, which has kind of come out of the gates this year or last year, with their totally flat to the ground solution, which is interesting. I'm concerned, both of these systems are great because they get very high GCR. So if you're trying to create density and you're limited to the amount of real estate you have, it's a great solution. And then there's the high wind aspect, which we will also talk about. So there's high GCR, high density, very low wind resistance overall because it's a solid surface, basically, right?
Yeah, we're having about crew size of about 9 to 11 guys installing 1 megawatt per week. So they're able to install it quite quickly. It's very low cost, probably half the cost of any other fixed tilt solution. Easy for logistics. Also for the boundaries of the site, you can align the modules with not just north-south oriented, but we have east-west, north-south, and in between. Because of the low tilt of the modules, we can also face it in any direction. So that makes it even more better for land use, being able to take advantage fully of the site, essentially.
I don't know what you mean by the orientation and land use.
So north-south doesn't have to be north-south. It could be east-west orientated, north-south orientated, or in between. We could generally go along with the boundaries of the site so that it can basically take up as much of the site as possible because we're at 8-degree tilt. So the yield variance is not going to be anything, very basically.
Why would you do north-south? I mean,
if you're somewhere like in Ecuador or closer to equator, like we have some systems there where they want to do north-south because the orientation of this site was better for that. So,
gotcha. You have to be careful. You said something that immediately was a red flag for me. I have to be honest. You said it's probably half the cost of other systems. And you have to be clear about what you're talking about. Is it the cost of the equipment? Is it the total installed cost? When you say it's cheaper, what is cheaper about the PEG?
Yeah, so the material cost, I would say, is generally around half the cost of the foundations and the racking itself.
Okay.
For installation costs, we can provide man-hour effort for installation, and the tools are generally a lot cheaper as well. But we'd have to kind of look at the CapEx on a project-specific basis depending on the country.
Yeah. And I was a fan of Nuance back in the day, the Osprey. We did an Osprey installation at Continental, and it was a double edge. You didn't need heavy equipment, but you're still driving something into the ground, and that worker who's running that machine, it's extremely laborious for the worker. So that also is a double edge. Less heavy equipment might be good, but actually the workers, they like using machines and not putting a lot of fatigue on their body. And so if in the Nuance case, you're driving a cable with a toggle on the end into the ground, in your case, you're driving a piece of rebar into the ground. How exactly do you do that, and how deep is the rebar going?
So the piece of rebar will just be with a hammer drill. Basically, it takes about 15, 20 seconds, going about 2.5 feet in the ground. It'll depend on the pull-out test eventually, depending on the soil conditions, all that stuff. If it's softer soil or sand, it would basically be a helical screw. We can adjust the size of the screw. It's with a 2-man auger. So basically, instead of digging a hole with it, you're twisting a rod into the ground with it.
Yeah. So 2 feet down, and then the rebar sticks up about 3 feet, or how tall is it?
Yeah, approximately 3 feet. It's about waist level high. So the highest point, I'm usually thinking in meters, but yeah, it's about 1 meter at the tallest point.
Yeah. So it's very low to the ground. And sorry?
Ergonomic height for kind of installing and putting the modules on there so that you're not kind of lifting them up high or anything like that. It's more waist level.
Is the process of wiring the modules relatively easy? Do the workers like it, or?
Yeah, because everything's above ground, so I could show you a quick photo here. This is kind of underneath the array, where you're just connecting as you go. Cable management's on the outside. It's easily accessible. You can have kind of trays going straight to the inverters.
We don't see anything.
Oh. So yeah, this is going to be installation of the modules. This is kind of the guy hammering in the rods, installing, crimping, installing the modules, waist level high, you can see. And underneath is kind of connect as you go, or you go back and connect them, and then everything's above ground with DC from the outside of the blocks all the way through the inverters.
This is in Australia, those photos?
Yeah, those were in Australia.
Yeah. So what is the, let's talk about your footprint so far. You're a German company originally.
Yep.
And you're the head of business development for North America, but you're getting traction in a few different places around the world. So what's the status of your footprint?
Yeah, so we have about 200 megawatts in Australia. That's where we first started out. We had guys installing, I think, back in 2015 there. Some farmers that said we can't grow anymore because of all the droughts, but we can have solar. So they switched from farming to solar. Mm-hmm. Installed 9 megawatts from the get-go without our help at all. And then it kind of went from there. So that's one of our most developed markets. They're basically doing regional Australia and the outback and stuff, and integrating energy storage with the solar for clients out there. We have about 100 megawatts, I would say, probably in the Netherlands, because it's very flat there. They're very land constrained. So they really like the solution on those aspects. Did a couple landfills over there as well. And then we're on every inhabited continent with at least some form of a project. I think we're in about 30 different countries too with the PEG. So it's pretty easy to start a new PEG project because it's so easy to mobilize and simple solution. And
so the product has been around for a decade, but when was your first North American installation?
Just last year. So we have one in Florida now.
Florida, you said?
Yeah, it's been a while to try and get some stuff in the ground and convince people kind of the solution, get the bankability reports from DNV and the UL and all that stuff. Yeah. We do have an 8.4 megawatt in Cuba that's being finalized now too, though, for North America.
Meaning the installation is underway?
Yeah, it has about 1 more megawatt left out of the 8.4.
Mm-hmm. Yeah, let's talk about the Caribbean. We were talking in the pre-show that your system is very wind resistant. And of course, we are very cognizant of hurricanes here in the U.S., especially if you live on the Gulf Coast. Talk about high wind resistance.
Yeah, so there's basically no uplift on the solution, or very minimal. We've done extensive wind tunnel tests with IFI in Germany, and basically with a 550 watt module, we can handle about 160 miles per hour with a category C for ASCII code 7-10. With a 450 watt, we can handle about 170 for category C wind exposure. So it's very well suited for those high wind environments because it's low to the ground, minimal uplift. It also has a point of connection on each 4 corners of the module, so we keep it down on the ground very well. Then we'll use like a helical screw to keep it in the ground from being pulled out, depending on the size, depends on the soil conditions. And then we can also do like a pre-drilled into limestone solution as well, with just a regular rebar getting shoved in there. Concrete might be needed, depends on the pool test, but most of the time it's not needed for limestone type solution.
I didn't catch that last thing you were saying. Lightning?
Sorry. Basically, you can pre-drill like a 16 or 15 millimeter hole into limestone, and then just hammer drill in the rebar to that hole, and we can have a solution for limestone as well in the Caribbean. It makes it pretty attractive.
Okay. Where does that kind of terrain occur? Limestone?
Barbados, Turks and Caicos. Okay. A lot of the island has just maybe a little bit of vegetation on the top, and then it goes straight to limestone or harder rock.
Gotcha.
We only need about 0.5 meters of soil with our helical screws. We can also go into like sand, for example. So it kind of depends on the site. So
it can withstand 170 miles an hour. Is that what you said?
Yeah, that's just their standard solution. If we wanted to make it a hybrid high load solution, we could go above 185. So it depends on the site. Mm-hmm. We also have a site getting installed right now in Philippines. It will be a high load solution that will be for above 175 or something like that. Later this year.
Yep. Yeah. So, where real estate is precious, You mentioned the Netherlands, the islands, of course, the Caribbean. They're landlocked. They're constrained. They don't have a lot of real estate resources, or there's a lot of terrain. So makes sense. And then, of course, storms, and being storm resistant and resilient to hurricanes is vital in the Caribbean. It's an absolute must, right? And now, codes are making that a requirement. So, as it should be. But where else in the U.S. besides the Southeast now are you, the U.S. or Canada, are you getting traction?
So we're getting some traction. I think in California, we might be getting a balanced solution site that had asbestos for brownfield. Basically being able to maximize some of these brownfield sites to maximize the production. I know that in Maryland and New York, they allow multiple, I think approximately 5 megawatt AC sites on one piece of land. So being able to maximize those is often quite useful to increase the DC capacity. Yeah. We're looking at a few sites probably in Texas later this year as well. So it just depends.
So how big is a 5 megawatt PEG array using just say a 550 watt module?
So generally with a 550 watt, we're about 0.75 to 0.8 megawatts per acre. I would have to do the calculations really quick before we get back into them from that figure, but.
Yeah, do that. Do that math for us if you would. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
Yeah, so about 6.25 acres per 5 megawatts. Yeah. And then if you had it at a 1.3 AC-DC ratio for the DC size, you might do a 1.8 acres, 8.1, acres.
Yeah. Yeah, so it's at least twice as dense as a fixed tilt or tracker. You know, a rule of thumb I use in designing for tracker or fixed tilt really is 5 acres per megawatt. So this is quite a bit denser than that. And you talked a little bit about the installation. That looks very straightforward. Maintenance, both of the array and the vegetation or, weeds. You're not going to get much growing underneath it because it is so dense, but you will get there are cracks and weeds will find their way. It's amazing to see, especially fixed tilt arrays that don't get mowed often enough or weed whacked, or the right plantings. That's really what you want to think about is the right seed mix and the right establishment protocol. Yeah. But talk about those things.
Yeah, so let me just show some pictures of this. Basically, we have access. So what steps this apart from Earthos or 5D would be that you can access underneath the array. You can change a module with a 12-volt Milwaukee battery here and kind of just undo the clip and take out the module from underneath. You can also access underneath with cart. After you do a drone inspection, for the most part, to find any troublesome areas. For the module cleaning, it's just a brush that 2 guys can pull on a rope or robotics. And then for underneath for vegetation, we have robotic mowing solution, fabric weed barrier, or you can plant something like clover grass. It's a low growing, and then we're also testing out sheep over in the Netherlands, depending on what you find out.
Yeah, leave that slide up if you would. The robotic mowing, is that a third-party product or something that Jurchen makes?
So this one is from Remo. We're working on having it fully automated by the end of Q2 this year. Mm-hmm. And yeah, that's kind of a third party.
Okay. The fabric, of course, is a possibility.
Probably not in the Northeast for certain areas. If you have a slope to the site, you're going to want to avoid it for storm water. You can probably keep vegetation underneath with a robotic mower.
Mm-hmm.
And then it does grow vegetation underneath. We have sites in Ireland that does grow the vegetation, but it is a bit slower. So for stormwater management, people ask, hey, you won't be able to keep anything vegetated underneath, but it does keep vegetation. So that's something to note as well.
So have you developed a seed mix that works well in different areas for the peg?
Most people in Germany and Netherlands, they just plant on top. They just install right on top of an existing field. So they haven't done that in the past.
Mm-hmm.
You can also adjust the amount of height that the solution is off from the ground. Normally it's about 0.8 meters, but we can increase that to about 1.2. That gives you a little bit more distance for growth.
Mm-hmm.
I know in Israel, they let the vegetation kind of grow and then die in the summer without kind of doing much vegetation control for some areas. So it kind of just depends on the site and what you expect for vegetation. But generally, we would recommend a white clover or something low growing.
Gotcha. And I see some sheep there. Where is that photo from?
It's in the Netherlands. Basically, those are miniature French Moussin sheep, I believe, where they basically cordon it off, preventing them from being able to get on top of the array, and then they kind of shift them from block to block. And give them.
So they're using them for vegetation management?
Yes. But
Okay.
They keep them fed a little bit so that they don't eat the wires as well.
Don't want the sheep to be too hungry.
No.
Oh, that's funny. All right. What about snow load? That was, when I first started looking at this and doing some designs with the peg, it does pencil. The density is wonderful, but in the Great Lakes, I worry about snow load and ice damming. What are your experiences so far with that?
So we're looking at some stuff in Alberta, Canada right now. For snow loading, I mean, if it's going to be a huge downpour of like 4 or 5 inches, there's going to be some buildup on there and it's going to probably disappear. And you're going to have to model it similar to you would an east-west 8 degrees on a rooftop.
Mm-hmm.
So in Canada, they're looking at sites that are like a part of an embankment. It's part of the farmer's irrigation system that they only need kind of really during the summer. Or something that's a use case in that aspect. But in general, for other sites that are kind of like Maryland or closer to the water, we would imagine it takes a couple of days to melt off, similar to Germany. For damming, I would recommend kind of the module clips that allow drainage to prevent ice damming within the module itself. For snow loads, we have a Eureka 550 watt approved to about 50 PSF. But generally, I would keep it around 35, 30 to make it so that we have a wider selection of modules available. And then the snow damming isn't as much for those type of sites. That's kind of where I would imagine we'd stop penciling as well, as above the 35 PSF mark.
Okay. So what else should developers and EPCs and installers know about the system? What are the lead times? And I guess if you have references, you mentioned the UL certification. I'm curious about that as well. But yeah, from an EPC developer perspective, what should our listeners know?
Well, I think that the future, the PEG is going to be replacing trackers once we reach a certain price per watt peak for modules. I think that price is going to be around 26, 25 cents per watt. Right now, I know we're at 42. So right now, we're going to have a land-to-train site. It's like a balanced solution for a landfill or a brownfield site or a site that's connected with energy storage where the client wants the cheap DC side in order to feed into the energy storage. And then longer term, I think hydrogen production, the PEG would be very well suited for something like that. We're working on automating our rod installation. We have the automated robotic mower, the unskilled labor. You're seeing all these labor shortages because of the IRA. If we're able to utilize labor that's not as utilized because we can use unskilled, I think that will give us an advantage. The high density of the PEG for hydrogen production makes us an advantage, and then lower use of materials. Overall, the lead time is about 12, 14 weeks from PO. And then it's delivered around 4 to 8 megawatts per week, depending on kind of what we need to ramp up to for the site.
I didn't quite, go ahead and turn off the screen share if you would. I didn't quite understand the point you made about module pricing.
Yeah. So when you have an expensive module, you want to get maximize the use out of it. You want to get a high yield, you want to track the sun, and you want to get maximum use because it's an expensive piece of equipment. Mm-hmm. But as the price of modules comes down, it becomes a less expensive piece of equipment that maybe you want to just put into a field as cheaply and as quickly as possible, mm-hmm. so that you can utilize it better that way, where we make up the CapEx and save on the CapEx side rather than having to get really expensive equipment to track something that's not as valuable anymore. So places like Africa or Caribbean, where these module prices are already half the price of the US, then it makes a lot more sense in those areas because you're going to want a fixed tilt usually for those type of systems, and high density and the lower cost of the peg kind of combines better when the modules are cheaper, similar to Earth's system.
Interesting. I never thought about that. I love trackers. The insulation that you get, the kWh per kWp with a tracker here in the Great Lakes is 1,600, and you can't achieve that with rooftop, until you're in Arizona. So it is a nice bump to the production, but you've also got a mechanical device then that can break.
Yeah.
And it's an experiment that we're doing basically, just as the industry is growing now in leaps and bounds, installing large quantities of trackers in the field in harsh environments. California is one thing, but the Great Lakes is another thing. It's very hot and humid in the summer, and it's very, very cold and snowy and windy in the winter. And so it's just it's apples and oranges, really. But
yeah, the OpEx savings you can have with fixed tilt, we can do larger rebar that can have up to 45, 50-year design life too. You could just sit out in the field, high density, basically an ocean of solar panels that would be a very long design life too. So yeah. So there are some efficiencies here with the peg that I do really like, because one of the complaints is that, well, we're converting too much ag land to solar, and if you just Google that problem, there are some really solid analyses of this now, how much real estate we need to completely green the grid with wind, solar, and expanding the transmission infrastructure, right? Plus hydrogen eventually too, that will take even more.
Yeah, but these numbers are not big. We need 1 to 2% of the landscape to completely green the grid and electrify everything. So we're swimming in real estate. But in certain places, we're not swimming in real estate, like New Jersey. You can't develop solar on ag land unless it's dual-use solar. New Jersey is a very small state. It's the size of Israel, and it's very dense. And, of course, they want to protect their farm ground. In Illinois, we're swimming in farm ground, huge quantities of it being used for ethanol, corn to ethanol, which is 100 times less efficient on an energetic basis than PV. So we have plenty of land resources, and so that's really not a concern. But there are plenty of places where real estate is very, very valuable. And so we need a variety of solutions.
The IRA made it very valuable for low-income brownfield sites, especially. I know that those are going to be pretty good for us in terms of the land use.
Yeah, and brownfield solar, I love it. It's a great repurposing of brownfields, and there's not much else you can do with a brownfield except turn it into a bright field with a solar array on top. It doesn't remove the risks of there being a landfill there, right? There's still a landfill there, but now at least you're producing clean energy with that ground that otherwise it's just sitting there doing whatever it's doing. Landfills are hazards, and that's why communities don't want them anymore. And and we're running out of landfill space. But anyway,
Yeah.
So when you do a landfill, though, you typically can't penetrate the ground if it's a capped landfill. So you're using a concrete foundation, or what kind of foundation?
So there's multiple foundations we can use. The primary one everyone looks like nice and neat is a concrete, but we can also use recycled construction material for ours because we don't need that deep of a foundation. So basically, one of the items that we recently came up with, it's not that pretty, but it's a lot greener. It's something like this, where you have a high density plastic that's designed to be outdoors for a long duration. You can fill it with a recycled concrete or recycled asphalt.
Okay.
The ballast solution.
Gotcha.
But yeah.
Yeah, making ballast blocks. Of course, you can make ballast out of many different things. In the ballasted ground mount projects I've seen, they're using just concrete and either pour in place or precast, and but it's a thing. So, what else should we know about the PEG? I really appreciate this dive into your product. It's great to see you getting traction, and I look forward to visiting my first PEG project. I don't know where that's going to be, but what else should we know, Matthew?
Basically, it's just perfect and I like it for the Caribbean, brownfield sites in the U.S. Long-term, it's going to be hydrogen. Long-term, once we get the white watt peak pricing there for modules, I think it'll be replacing trackers eventually. There's a lot to happen this year, and maybe we'll reconnect, and I'll have several projects hopefully by the end of the year here.
Sounds good. And you mentioned automating the pile installation or the rebar installation. You call them piles? How do you refer to the foundation?
Yeah, piles is fine.
Yeah. So how far are we away from robotizing a field of PEG piles? So
basically, we had a prototype for about 5 years ago or 3 years ago that got put on the sidelines during the electric RWE, EON, NOG combination. And now about a month ago, we started looking back into this because we're talking to some large players for hydrogen potential integration and gigawatt scale globally that pairs well. And the main thing that they're looking at is automating processes. And that's probably one of the easiest processes to automate on our end. Yeah. It's a raw addition. So I'd say hopefully by the end of this year, unless we had someone come in that said we want this to happen sooner and gives us a project, that always helps move things along quicker. But it's in development, and we have a working prototype that's getting the kinks worked out basically at the moment.
Great. Well, you can find all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple or Spotify. That is the best way you can support the show. If you're a potential corporate sponsor, please reach out to me directly. And with that, Matthew, how can our listeners find you?
They can find me on Jurchen-technology.com or Matthew.Lusk@Jurchen-technology.com for an email. I'm happy to follow up with them. Anyone that is interested in learning more.
Wonderful. We will put your links in the show notes. And with that, I want to say, let's grow solar and storage. I'm Tim Montague. Thanks, Matthew. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.